In the last video, I showed how to use the server log connector to publish alerts to a log file. Then I used Logstash to ingest the alerts in the log file and relay them to your email. But that method might not offer enough flexibility for some people. So in this video, I will show how to use the index connector to publish alerts to an index in Elasticsearch. Then I will provide an app that will ingest the alerts in the index and relay them to your email inbox. The app is written in Golang, and you will have access to my source code in case you want to use it as a starting point to make connectors to other third-party services. So I'm going to click to the menu, click to the alerts, and let's click on Manage Rules. Let's work with the error count. I will edit this rule. So we already have some connectors from the server log demonstration. Let's add another connector, the index. Let's create a connector. Give it any name we want. Let's just say connector 3. Right? Give it something more meaningful than that in your production environment. And we're going to write to an index. Before we write to an index, we should create the index, right? And part of the reason why I want to create the index manually is because I want to specify the schema, not the schema, the mappings myself. All right, I want to be very specific in the mappings and what properties we're tracking. So let's go to DevTools because we are going to create an index. You can see that I've done some, I'll just keep this here. When you come to the DevTools for the first time, you probably won't have all this. This is just by cookies, or Kibana has memorized some of the alerts that some of the commands I've run previously. But the first command we're going to run is we're going to do a put statement to the API and create an index called Kibana alert. You can call this anything you want. I'll just call it Kibana alert because it's easy for me to remember. Right? So we'll create the index, right? So the index has been made. It's going to be empty. In fact, you can check it by going over to Stack Management, clicking on Index Management. You can see that we've now created a new index here. It's got 0 documents. The mapping, it's got no fields or no mappings or properties mentioned. And if we start pushing alerts to this index right away, Kibana and Elastic is going to automatically generate the mappings for you. But I don't want to do that. I want to be more specific and have a more efficient mapping specification. So let's go back to DevTools and specify our own mappings. So I want to track the alert ID. I want to track the date. I want to track a reason. I want to track a rule ID, and I want to track a service name. So for the reason, I'll start with this one. The reason, I'll just store it as text. Whereas the alert and rule ID, I want to store it as keywords. The reason is because Elastic is going to do some text analyzing. And if you, when a field is stored as text and you do a query against that field, so let's say reason is stored as text, and we do query keyword searches against reason, or we do any kind of text search against reason, it's going to tokenize our search query. So if there are spaces between words, it'll split those up into individual terms and then search the index using or, and statements or other interesting expressions. But for the alert ID and rule ID, because the alert ID, they're actually going to be, the alert ID is formatted in a very, it's got many alphanumeric characters separated by hyphens. And when I search for an alert ID, I want to do an exact match of that ID. I don't want Elastic to split up that string or based on the hyphen delimiter and then doing some other complex queries. I want an exact match based on that alert ID. That's why I've chosen keyword. So if I'm kind of messing up my explanation, maybe in a future video, I'll talk about text analyzing and setting up setting up indexes and how to map them. But for now, just choose alert ID type text, rule ID type keyword. Reason could be text or keyword if you plan to do some or and and statements to match on certain words. Text would be better. So I'll do that. You can also do text and keyword, but you know what? Don't do that. Just keep it to text for now. All right, so that's my mapping, and I am going to do the mapping. So I think I can now, whoops, escape. How do I escape? So when I search the mappings, you can see that it's been properly mapped. And if I go to, also in Stack Management, if I go to Index Management, I click on Kibana Alert, you should be able to see that the mappings are here as well. All right, so we've got an index with the mapping specified, and we're ready to write documents with these properties to this index. So now let's actually work with the index connector. Let me go back to alerts. Click to manage rules. I will edit the error count, and let's come back to connectors. I want to add an index connector, create a connector. We'll just call it connector 3. And the Kibana alert yeah, there we go. So we're going to write to this index. We'll go ahead and refresh it. You know what? Yeah, let's do that and press save. And so we've got that connector. So we've got a total of 3 connectors here, with the third one being the index connector. Let's actually save. Oh, right, we're not done yet, because we need to state the template or the schema of the alert. And let's actually do this. I'm going to copy. So we want to write this JSON object to the Kibana alert index, right? And again, if you don't know, if you want other variables, you can pick them from here. But when you do, just make sure your mapping has that field so that it's properly recorded. Okay, so let's just press save, and hopefully no errors occur. All right, so I think the error count rule is now publishing alerts to the index, as well as all the logs that we've set up earlier. And we can double check that by going to Stack Management. And let's click on Index Management, Kibana Alert. Oh, actually, there. Yep, you can already see one document has been added. And maybe in another minute, this count should go up. The other way we can check it is to actually query for the, let's go to DevTools. Let's actually run a query against the index. Let's see, this was from my previous example. So I'm going to, let's say, delete these. And actually, you know what, I'll just run a query that I have in my notes. So I'm just going to run this query. Or actually, you know what, I'm just going to not even run a query. I'll just search everything. And you can see 2 records came back, and the hits are this alert, the error count alert, and this other error count alert. Let's add more. Let's go to alerts. And what I want to do is I want to update each rule and have all their alerts published to the same index. So let's do the same thing over here. Scroll down. And let's add an index connector. We'll also use connector 3. And the template, do I still have it in my clipboard? Yep. All right, great. So we will do the same message, save, And let's also do the latency one. And index. And let's go to DevTools and query our index. And we've got 3 rules, 3 alerts. All 3 are error counts, but I think momentarily we should see some failed transaction alerts as well as latency. Let me press refresh again. 4 results. Error count, error count. There we go, a failed transaction one. I had to pause the video for a moment just because there were some interruptions in my office. But anyway, I'm back now. So I think the last thing I was saying was that we got all the alerts into the Elasticsearch index. Okay, so there's a lot now. There's 193 alerts in the index now. I guess it's been about an hour or so. And you can see there are failed transaction alerts, error count alerts, latency alerts. So they're all in here now. So I think the next thing we need to do is to get the alerts out of this index and into a different service. So let's say into our email inbox. And I have an app that you guys can use. So it's going to be found in my repository, and I'll share this repository link in the description of this video. And I have a little bit of a guide here. There's only 2 things you need. You need a binary executable called run, which I have in this folder here. And you just have to populate an environment variable. And then you can just go ahead and run the binary file. So if I click into the binary folder, so I could just right click this and download to my Linux server. And then go ahead and update this environment file. So in terms of what this binary file does, I use Golang to compile this source code. So you have access to the source code folder as well. And I'll create that binary file if you ever need to make any edits. But in terms of what this run binary file does, it runs really this run.go script that I created over here. Right, so this is the script that generates that run binary file. And this might be a little bit verbose, so let me just simplify it for you. Really, this is all that this run.go script does, right? So this is pseudocode representation of the code that you're seeing here. What this is saying is I'm going to start a hash table or key value pair type of variable where the key is the rule ID. So a Kibana rule, like this rule ID, for example. So that's the key. And the value is going to be an alert ID. So let's say this alert ID, not alert. Okay, you know what? Future upgrade. It's not the alert ID. It's actually the hit ID, HIT ID. All right, so I'll make an edit to the source code in the future. But this last sent alerts is rule ID to hit ID. So we're going to keep track of the most recent hit ID that was emailed or notified. Then I'll start an infinite loop. First thing I'm going to do is ping the Kibana REST API and get a list of all the rules. So in that case, we'll have 3. We'll have this. We're going to get a return of this rule ID and a return of this rule ID. Sorry, those are the same. Anyway, there's only 3. There's the failed transaction rate. There's the error count rule ID, and there's the latency rule ID. So we're going to get a list of 3 when we ping the Kibana API. And then we're going to loop through each of the rules. And for each rule, get the most recent alert ID. If that most recent alert ID is not the same as the alert ID stored in our key value table, send a notification with the alert details. And then update the hash table to say that that was the last sent alert ID. Wait 10 seconds and repeat everything all over again. Right? Or actually this 10 seconds, it's a variable, it's an environment variable that you can update. I default it to 60 seconds, I think. So let me I defaulted to 10 seconds. Yeah, so that's right. Okay, so that's all this script does. Now this command here basically runs a curl statement to the Kibana API. So I actually have that over here. So to get a list of all rules, I'm using Golang to basically run this curl command, which is go to this API endpoint and fetch me a list of all the rules. We're going to use the super user Elastic and this password. This is actually not good. I don't want to use such a privileged user for this, but I'm just showing that here for demonstration purposes, right? So we basically just take this command, and Golang, or the binary file, is basically just going to run this, and we get a list of all the rules, right? Okay, so this is actually hard to see. So I'm going to pipe it through this JQ command that I have installed on the computer. And you can see that that API endpoint gives us a list of all the rules that exist. And let me just scroll to the top. We have the error count rule, the failed transaction rule, and you can see the rule ID over here, because later we're going to find all alerts based on this rule ID. And then this one is I must have missed it. Oh, latency, right? This is the latency. And this is the latency rule ID. So that's what this function does. It makes that curl statement. Then for each rule, get all the alerts by rule ID, which is basically this curl request here. This one was ping the Kibana API endpoint. This one's going to ping the Elastic endpoint. Find me all alerts with this rule ID. So that would be this rule ID. So I guess we're getting the latency one. I only want one result, and I want it sorted in descending order. All right, so let's take this. And you can see that the most recent alert ID, so this hit ID, is going to be returned. So that's all this script does, which is saying that's what all this run.go does, right? And yeah, so if you want to modify the code, you can do that here, but we don't need to do any of that. We can just go straight to using the binary file that I've already compiled for a Linux machine. In fact, I have it on my computer here. Yep. Yep, so it's all here. So all we have to do is update the environment files, or the environment variable. We're going to need the API key of the user that's going to hit the API. So I mentioned I don't like using such a privileged user with this username password. So I'm going to create a new user, and we're not going to pass in human readable credentials like this. I'm going to use an API token instead. So let's go ahead and create a new user just for this app. So I'm going to come over here, go to Stack Management, click to Users, and we're going to create a new user. I'll call it the Alert Reader. Alert Reader. I don't really care what email we use because I don't intend on resetting passwords or anything like that. Let's generate a random secure password. I don't really intend to log in as this user. Now the important part is setting up the viewer role, right? So this is going to be almost like a read-only user, right? So let's create this user. All right. And now we're going to need to create an API token for this user. Oh, you know what? I do need to know the password of this user to be able to create the API token. So let me change it to something simple. ABCD1234. All right. And now we can go to DevTools. All right, I'm going to make a post to this endpoint, host slash underscore security and API key, because I want to generate API key. And I'm going to do it on behalf. I'm logged in as the Elastic super user, and I'm going to do it on behalf of the alert user. And to do the alert user, I'm going to authenticate with this password grant type. So this is the password for this user. And we're going to give a name to this key. We're going to call it the alert user key. So I'm going to go ahead and create that. Unable to, okay, so what is the reason? Oh, I might not be able to do it through here. Maybe I have to do it through the command line. Oh, okay, so let me just see what the issue is. Maybe there was a typing mistake in my password. So I'm going to pause the video and try to troubleshoot what's going on. So hold on. Okay, I figured it was a typing mistake. I wrote alert user. It was supposed to be alert reader. And then I pressed play button. And here you can see that this is the API key that we will be using. So I'm going to copy and save this to a text file. So maybe I'll save it over here. And we're going to need this. And we're going to paste it into our environment file here. All right. Okay, so we've got that. Oh, and by the way, you should be able to see a list of all the API keys here as well. If you ever need to revoke them, under stack management, users API keys. So you can see it also created here, and you can disable them here. When creating API keys, you could actually create one here, but it'll only be for the Elastic user. You'd have to be logged in as that alert reader user to be able to generate. Oh, you have to be logged in as the alert reader user, and you have to have super or more privileged access to be able to generate API keys. As a viewer role, you won't be able to generate the API keys here. So that's why I didn't do any of the API key generation through here, and I did it straight from the dev tools. All right. Anyway, so we've pasted in the alert reader user key in here. The index we're going to read from is the Kibana alert because that's what we've been querying. So wait, let me just go back here and make sure there's no spelling mistakes. Right? Yeah, Kibana alert. So that's the index name, Kibana alert. The while loop is going to be 10 seconds. So that would be, so we're setting this to 10 seconds. And that way, if the same alert happens again, we'll just skip it. I have some logic that will do that. Anyway, so scan every 10 seconds. I'm going to turn on debug mode. It just makes things a little bit more verbose when we're running the scripts. But you can set this, as long as it's 1, the debug mode will be on. You can set it to 0 or any other value, and then it won't be as verbose. In terms of the notification methods, I could do both a SendGrid REST API connection and SMTP. Before this first demonstration, I want to use only SMTP. We're going to send from the username John, from this email address, user1@email.com. We'll send to user2 and user3@email.com. These are the SMTP connections for our mail trap. Actually, these might be out of date. Let me just double check. E21 and A2F. E20. Okay, no, these seem correct. Yeah, okay, so these are the SMTP details. I haven't put in the SendGrid details yet because we're going to test just the SMTP. So I think that's it. Let's go ahead and try this out. .run. And, all right, so a notification has been sent for these 3 alerts. SMTP, I think there's just some throttling in Mailtrap that prevents us from sending too many requests. So yeah, don't worry about that. But you can see that the emails have actually showed up in SMTP. Okay, this is skipping because this was already sent. Yeah. All right. So if the alert has already been sent, it won't send it again. And it'll scan every 10 seconds and it'll update that hash table. Right. So that's all there is to this binary script. Now, the other option that I showed was that we can also send things via SendGrid. So what I'll do is I will uncomment this. Right. And I'm gonna, so what this does is if we do this, a comma separated list of notification methods, it will do a send transmission through SMTP at Mailtrap, and it will also do the same transmissions through the SendGrid API, which is another transactional SMTP service. And later on, I'll show you how you can build more adapters if you want more notification methods in here. But I'm gonna pause the video and actually update these with real SendGrid API credentials before continuing. Okay, so I've made the update. I am going to, let's just clear some of this garbage out. Okay, and let's run this. So now we should get something in here in Mailtrap, and we should also get something in my Gmail inbox. Okay, yep, got it. So I'm just going to take a screenshot of I'm going to pause this so I don't overwork the system. Let me take a screenshot of my Gmail inbox because I don't want to disclose some of my email settings in my Gmail. So taking screenshot. Right, so yeah, so things are coming into my Gmail while we were running the script. So that's all there is to this binary script. You don't need to have Golang installed, you can just run it. But if you want to, you do have access to the source code here in case you want to make any edits. Okay, so one other thing I'll mention is that I said this send notification can send through SMTP or SendGrid API. That function is found in this folder over here. And I have this notify.go, and here you can see a map of so these are the options available to you in your environment file, and then they will map to each one of these functions, a SendGrid function or SMTP function. So if you're going to make additional adapters, let's say one for Trello or another one for Asana, just list the key here and then create a function that connects to Asana, right? And that function must accept alerts.source, which is a struct. Let me just show you in the code here. Alerts, which is just this struct over here, right? You have to pass in these options that come from the REST API in the JSON. In the JSON response from the REST API, you're going to get these 5 properties, and then it'll be written to that source object, and that source object needs to be passed into your function, because once it's in the function, then you can look at one of these other functions as an example. Once you've passed it in to your function, you can do whatever you want with it, make any other API calls to it. The SMTP does the same thing, right? Accepts the alert source, and then you can do whatever you need to do with it. I'm going to update some of the code to format things a little bit better. But yeah, so that's something you can work from if you need to use the Golang, this Golang app. So I think that concludes this final part of alerts in APM with Kibana. So hopefully you find everything I've done useful. And if you have any questions or feedback, just leave in the comments of this video. And if you have requests for any other instructional videos you want me to make around Elastic, let me know, and I'll do some research and see if I can put together a video for you.